Smart Figure 18.9 Measuring the movement of a glacier. Ice movement and changes in the terminus of Rhone Glacier, Switzerland. In this classic study of a valley glacier, the movement of stakes clearly shows that glacial ice moves and that movement along the sides of the glacier is slower than movement in the center. Also notice that even though the ice front was retreating, the ice within the glacier was advancing. Animation. Glacial advance and retreat. Your browser doesn't support
the flow of ice within a glacier. Glacial ice originates as snowfall in the upper parts of a glacier, in the region known as the accumulation zone. In a mountain glacier, such as the one you see here, the accumulation zone is the higher elevation part of the glacier, where annual snowfall is often greater and the rate of melting is lower than in the lower elevation part of the glacier. In the lower part of the glacier, there is greater ablation, or wasting away of the ice through melting and sublimation, than in the higher part of the glacier. The equilibrium line marks the location on a glacier where accumulation matches ablation. Above the equilibrium line, accumulation exceeds ablation, while below the equilibrium line, ablation exceeds accumulation. In the accumulation zone, old snow, still frozen at the end of summer, is covered by the first new snow of winter. The old snow is eventually compacted into dense granules called firn or névé. Over time, firn is transformed into glacial ice. When the thickness of ice reaches about 50 meters, about 165 feet, the ice begins to flow. A glacier moves through the slow internal flow of ice and through basal slip, the sliding of ice over the rock below. The rate of movement is usually quite slow, typically a few centimeters a day. Notice that ice is constantly flowing within the glacier, and that the ice tends to flow fastest down the center of the glacier. New ice formed in the accumulation zone flows down valley to the lower part of the glacier, where it is eventually lost to ablation. Ice continues to flow even when the glacier remains the same length or is retreating. During times of high accumulation of ice, a glacier can flow farther down its valley before all of its ice is lost to ablation. At such times, when accumulation exceeds ablation and the glacier is advancing, the equilibrium line also shifts down valley. When the glacier reaches a new balance between accumulation and ablation, it once again becomes stable. During times when ablation is greater than the accumulation of ice, a glacier recedes. Such a glacial retreat occurs when the accumulation of snow and ice is small, or if higher annual temperatures increase the rate of ablation. Notice that the end or terminus of the glacier retreats up valley, even though the ice continues to flow downhill. When the glacier establishes a new balance between accumulation and ablation, it becomes stable once again. Among the landforms that may be left by retreating glaciers are terminal moraines and recessional moraines. These ridges of glacial till develop at the margin of the ice when a glacier stagnates for a period of time.
For many years, time-lapse photography has allowed us to observe glacial movement. Images are taken from the same vantage point on a regular basis, for example, once per day, over an extended span and then played back like a movie. More recently, satellites let us track the movement of glaciers and observe glacial behavior. This is especially useful because the remoteness and extreme weather associated with many glacial areas limit on-site study. How rapidly does glacial ice move? Average rates vary considerably from one glacier to another. Some glaciers move so slowly that trees and other vegetation may become well established in the debris that accumulates on the glacier's surface. Others advance up to several meters each day. Recent satellite imaging provided insights into movements within the Antarctic ice sheet. An examination of Figure 18.10 shows that portions of some outlet glaciers move at rates greater than 800 meters, 2,600 feet, per year. On the other hand, ice in some interior regions creeps along at less than 2 meters, 6.5 feet per year. Movement of some glaciers is characterized by occasional periods of extremely rapid advance called surges, followed by periods of much slower movement. Figure 18.10 Movement of Antarctic ice. These maps result from thousands of satellite measurements taken over several years. Outflow from the interior is organized into a series of drainage basins separated by ice divides. Flow is concentrated into narrow, mountain-bound glaciers or into relatively fast-moving ice streams surrounded by slower-moving ice. NASA. Budget of a glacier, accumulation versus wastage. Snow is the raw material from which glacial ice originates, therefore, glaciers form in areas where more snow falls in winter than melts during the summer. Glaciers are constantly gaining and losing ice. Glacial zones. Snow accumulation and ice formation occur in the zone of accumulation, figure 18.11. Its outer limits are defined by the snow line, or equilibrium line, the elevation at which the accumulation and wasting of glacial ice are equal. As noted earlier, the elevation of this boundary varies greatly, from sea level in polar regions to altitudes approaching 5,000 meters, 16,000 feet, near the equator. Above the snow line, in the zone of accumulation, the addition of snow thickens the glacier and promotes movement. Below the snow line is the zone of wastage. Here there is a net loss to the glacier as all of the snow from the previous winter melts, as does some of the glacial ice, see figure 18.11. Smart figure 18.11 Zones of a glacier. The snow line separates the zone of accumulation and the zone of wastage. Whether the ice front advances, retreats, or remains stationary depends on the balance or lack of balance between accumulation and wastage, ablation. Tutorial. The glacial budget. The loss of ice by a glacier is termed ablation. In addition,
hello, this is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe what influences the glacial budget. Glaciers flow downhill. This is an important realization to have in this discussion because we're going to watch the front of the glacier, the downhill end called the terminus, and that terminus is going to move, and it might move downhill or it might move uphill, but all the time the glacier is flowing downhill. The glacier has two regions that we need to pay attention to. Uphill is the zone of accumulation where more snow falls each winter than melts off each summer. At the bottom end of the glacier is the zone of wastage where all the snow from the previous winter melts, as well as some of the glacial ice itself. So whether the zone of accumulation ends up gaining more snow each winter or whether the zone of wastage ends up melting more glacial ice each summer ends up determining whether or not the glacier ends up growing or melting back. One form of wastage is simply melting, where the ice turns to water. Another form of wastage is what's called sublimation, where ice directly goes into the gas phase. That happens in really dry regions. And then there's also the possibility of calving icebergs. So some glaciers flow out to sea, and there they form ice shelves, and those ice shelves can break off, generating icebergs. The process of generating icebergs is referred to as calving. What would happen to a glacier which experiences first an increase in its glacial budget? In other words, the zone of accumulation gains more than is lost at the zone of wastage, and then undergoes a reversal of fortunes where the zone of accumulation ends up gaining less snow and the zone of wastage ends up losing more. What would end up happening to that glacier? Okay, you've had a moment to think about it. So I think first off, you would end up seeing that the glacier would advance because, again, there's more going in at the top end than is being lost at the bottom end. So the glacier grows. It might end up depositing a nice end moraine there as it grows. And then comes the period of time where there's less being added in than is being lost at the bottom end. So there's less accumulation and more wastage. At that point, the glacier is going to retreat. So the terminus of the glacier is going to back up, even though the glacier itself is flowing down the mountain the entire time. A new end moraine will be generated. And then, of course, the glacier might end up melting off entirely. And just by looking at the position of those two end moraines, we can end up deducing its history. Thanks very much for your attention. This has been another Smart Figure.